Welcome to Atomly. To build a chip that runs on light, scientists recreated the bottom of the ocean, then made it 100 times worse. Meet germanium and tin, two atoms that absolutely refuse to bond. So why force them? Because your chips have a heat problem. Inside them, data moves through copper wires as electricity, and electricity leaks heat the whole way. The dream fix? Move data with light instead. Fast, cool, no leaking. One problem: silicon is terrible at making light. Here's why. Electrons release energy by jumping a gap. In silicon, the jump is crooked, so the energy escapes as heat, not light. But add tin and the gap straightens out. Now the electron jumps clean and releases actual light. Perfect. Except, remember, these two still refuse to bond. So scientists got violent. 1200 degrees of heat, then 10 gigapascals of pressure. That's about 100 times the crushing pressure at the very bottom of the Mariana Trench. Under that, the atoms have no choice. They snap into a brand new hexagonal crystal, and the wild part, the bond stays. Even after you release the pressure, stable, at room temperature, like nothing happened. There's a limit though. Add more than about 16% tin, and the whole thing collapses back to boring cubic. Even forced marriages have boundaries. So no, this isn't a magic chip yet. It's a lab crystal that needed ocean-crushing pressure just to exist. Scaling it to a factory is the real boss fight. But if it scales, chips could finally talk in light. Faster data, far less wasted heat. And thank you for watching.